Hello students, today I am back with one more JEE advanced level question and I find this question very tricky and interesting. So let's dig in. The question is about the basic strength of the amines and you have to choose the correct statement or statements from the given options. Before you start reading the options, it's better to observe the molecules given here. The first two molecules are aromatic amines and the third and fourth molecules are aliphatic amines. This is quite important for our question. Why so? Because whenever there are amines, whether it's primary, secondary or tertiary amines, why they are basic in nature? Because of the lone pair of electron present on the nitrogen. It will be donated to the proton, hence we call this as base. Now, what will decide the basic strength of the amines? If there are electron donating groups, then the basic strength always increases. If there are electron withdrawing group, the basic strength always decreases. This is something opposite to what we have seen in the acidic strength of acids. Whenever we have aromatic amines, due to the resonance of the lone pair of electrons, the lone pair is not available for the incoming proton that easily. Hence, always remember the aromatic amines are less basic as compared to aliphatic amines. Keeping these concepts in mind, let's read out the statements and choose the correct options. Here, the option A refers to the order of basicity for the given molecules. This is a false statement because the order of basicity trend is actually 4 greater than 3 greater than 2 greater than 1. Why is it so? The molecule 4, which is also called as Quinuclidine, is quite basic as compared to triethylamine. Because in triethylamine, since it is open chain, there will be steric hindrance. Therefore, the nitrogen lone pair will not take up the proton that easily. But in case of quinacridine molecule, because there is a cyclic structure, there is not much steric hindrance on this nitrogen. Therefore, the lone pair will be given to the proton easily. And also, the inductive effect is more as compared to the triethylamine molecule. That's why 4 is greater than 3. However, these two molecules are greater than 1 and 2 because these are aliphatic amines. Since these are aromatic amines, the lone pair will be somewhat in resonance with the benzene ring. Hence, it's not easily available for the incoming proton. How are you going to justify that 2 is more basic than 1? For this, you need to know that there is ortho effect exhibited by the molecule 2. Because there are 2 methyl groups here, there will be steric hindrance. So, it will not let these lone pair to be in resonance with benzene ring because it will be out of plane. So the lone pair and the benzene ring, they are not in the same plane due to the steric hindrance caused by the 2 methyl group. So they are out of plane. Because of this, the lone pair will not easily undergo resonance. That means what? It's easily available for the incoming proton. That means it is a better base as compared to the molecule given as 1. Therefore, this is the right order. Hence, statement A is wrong. Statement B is that the second molecule doesn't couple with a phenyl diazo ion. This is a true statement. Compound 2, I'm going to rewrite this. Compound 2 is nothing but 2,6 dimethyl N, dimethyl aniline molecule. Because of the steric hindrance, the dimethyl amino group cannot conjugate effectively with the benzene ring. So, the ring is not sufficiently activated for the azo coupling with the diazo salt. So, as I told you earlier, due to the ortho effect, the lone pair is not undergoing resonance. That means it is not activating the benzene ring. Therefore, it will not couple. So, usually the coupling happens at the para position, right? Due to the donation of electron from the nitrogen. But that doesn't happen here because the lone pair is not undergoing resonance that easily due to ortho effect. So remember that. Therefore, this is the correct statement. Let's check for statement C. The complex formed by 3 and trimethylborane dissociate extremely readily. So that is something to do with the basic strength of the amine. So since it is not that basic, it will not form a stable adduct with the trimethylborane. Trimethylborane is like this, right? So triethylamine is this, right? So this will act as a base. That means this is Lewis acid and this is Lewis base. So it should give the lone pair to the empty orbital present on the boron. Will that happen? Not that easily because of the weak association of the Lewis acid and Lewis base. Therefore, C is also true. So let's check for the last statement. The magnitude of pKb difference between 1 and 2 is less than that between 3 and 4. This is a false statement. Why so? Because in 1 and 2, they differ much more in their aromatic resonance and also the ortho effect, that's nothing but steric effect. But in case of 3 and 4, both of the molecules have some positive inductive effect groups. It's just about one is open chain, the other one is a closed chain. Therefore, this is a wrong statement. 1 and 2 differ much more in their pKb values as compared to the 3 and 4 molecule. I hope I made this clear to you, and if you still have any questions based on the basicity, you can drop your questions in the comment section. Thank you for watching this video. Until next time.